It's part 12 now of the female reproductive system, and we continue on here. We're at page 1046 at this extensive figure here. We've come around this first half of the ovarian cycle and arrived at the Graafian follicle. Let's review this just very briefly. We started out with a group of follicles with providing enough tissue, the tissue being granulosa and thecal cells and granulosa, that under the influence of LH are going to produce lots of first estrogen and then progesterone. Notice that the granulosa cells are appearing first around the follicle as the follicle develops. Of course, this is under the influence of FSH, so follicle stimulating hormone is getting this to grow up, and then the granulosa cells are taking off also under that influence. And then finally, the granulosa cells under the influence of LH are producing estrogen. And then notice that the granulosa cells become stratified, and we begin to see thecal cells. And then we have lots of granulosa cells, lots of thecal cells. So more estrogen and more progesterone. And then we come down here, and we see this antral portion of the follicle, this antrum filled with fluid, the fluid referred to as liquor folliculi, and the egg that is referred to as an ovum surrounded by zona pellucida out here, and the corona radiata is this combination of granulosa cells and zona pellucida. If you bracket those two together, the correct term for that is the corona radiata, which surrounds the ovum. And the ovum here is sitting on a little, here it is, cumulus oophorus. That's the little column here of granulosa cells. And so we're going to burst out here due to a shift in the function of estrogen as a positive feedback system on LH, and LH is going to cause this little explosion, and we're going to have the ovulation of the egg, as you can see there. Okay, and the egg will be taken up by the oviduct, wherein it could be fertilized under the right conditions with adequate amounts of sperm available. And then what's left here at the end, after the egg leaves, this sort of closes up and heals, and we still have granulosa and thecal tissue producing estrogen and progesterone, now in ever higher amounts, because LH, which caused this event, was spiked. And now with a lot of LH and with a sudden spiking of both thecal cell output of progesterone and granulosa cell output of estrogen, we get a continuation here, and we have a full-on, at this point, corpus luteum, and it's really working well. What is it doing? It's producing that hormone that's going to make the endometrium grow up and differentiate and produce glandular output, glycoproteins, for the, hopefully by this point, fertilized egg, and now blastocyst, to implant and create a placenta. If there is no fertilized egg, if there is no implantation, and instead there is just simple outflow of the egg, then this will sort of disintegrate at the 14 days after ovulation moment and become ultimately the corpus albicans, which is a sort of granuloma here that's being, metabolized and remodeled by macrophages and so on. Okay, so that's that story, and you can review that a little bit We're going to be having a table coming up pretty soon that tells us much more about this. Now on page 1048, we have here, as you recall, this review here of the anterior pituitary, where we have FSH and LH. FSH comes out and stimulates the follicle itself to produce the developing ovum and all of these surrounding tissues of granulosa and thecal cells. Then we have the LH coming down, and that's going to be stimulating these androgens that are referred to as progesterone. Ultimately, the biosynthetic pathway will lead us to estrogens. Some of those androgens will be converted to estrogens, and there's going to be a mix, a variable mix in concentration and titer of how much estrogen. Initially, a lot more estrogen, and then later a significant amount of progesterone. So we're going to have to go over that, actually, because when it comes to the ovarian cycle and the uterine cycle of the monthly cycle, or whether it's going to be the pregnancy period of 40 weeks, it is estrogen that primes the pump. It's progesterone, ultimately, that maintains the stability of what's going on through each of these cycles, whether it's a monthly cycle or a 9-month cycle of development. It's the progesterone that gets us in combination with the estrogen to have the development of complex structures and the differentiation of tissues from one to another, plastique development. Okay, so then you'll notice here that we have this interesting, initially we have a negative feedback system, which maintains moderate amounts of estrogen, progesterone. Then over here, once we get to an antral follicle, then suddenly we get something that is more like positive feedback. So here I'm showing you positive signs in terms of the hypothalamus and the anterior pituitary, and we get a surge, in this case of LH. Instead of a negative feedback system that we were seeing over here, turning off the hypothalamus and pituitary, now we're seeing a turning on and a surge. And it's that surge that brings us the ovulated secondary oocyte that comes from the Graafian follicle. Okay, and then we get the resulting corpus luteum after that, and we return to negative feedback homeostasis once this occurs. Okay, so this will be graphically displayed in upcoming pictures, particularly this one. This is one of these pictures where you lay out your plastic ruler and go from left to right. And what you're doing is you're following a sequence of days up to the presumably 28th or 29th day out here. So, and we always begin with this period of menstrual phase to make clear, because there has to be a clear beginning period. And so I might spend more than one part here trying to rectify in our minds what's going on. Here in this first graph, which is mapped onto the 28 days, we have the plasma hormone levels. And you'll notice that LH and FSH are present here more or less in equal parts at the beginning. And then we get a surge here of the LH. Why does that happen? It's because the granulosa cells here suddenly begin to produce estrogen at a higher rate and cause that surge to occur. So they do give us these columns in the background features here so we can follow everything. We're starting off with primordial cells, primordial follicles, and then we're moving on to secondary and vesicular follicles. We're getting ovulation due to the LH surge. The LH surge happening because of the spike in estrogen. And then because we got that surge, now suddenly we're going to get stimulation of outflow for progesterone. Look at that outflow. And it's going to be high and it's going to be, I would have the crossing point more over here, but the idea is that this determines when we have menstruation. It also determines when we're going to have the baby, right? The estrogen progesterone relationship is very, very important right there. I'll come back to this in a moment for a second pass.